So you'll notice these all have hundred, thousands, a lot of zeros. This to me feels like, hint, hint, nudge, nudge, a multiple choice problem where maybe you have to figure out which answers give you this number. So make sure that for each one you're showing work so that you can get full credit. All right, first one, let's zoom it in. So that's going to be 10 to the, how many zeros? 3 to the 1/3. Yes, you're showing your work. And 10 to the first is 10. Okay. The next one, 100 is still 10 squared. It hasn't changed. To the 5 halves. 2 on top, 2 on bottom, bye-bye. 10 to the 5th power, 1, 2, 3, 4, 5. Even root, plus or minus. You know, you're going to put this at the top of your test. Maybe not like that. How about like this? Let's make sure you do that. Okay. And 10 to the 5th is reasonable for you to write out the answer. If it was 7 to the 5th, please leave it 7 to the 5th. Okay. But there's ones, if you can reasonably figure it out without a calculator, I would like you to figure it out. So this is 10 cubed squared to the 1/3. You don't need that many parentheses, but otherwise I think it was 32. So that's gone. 10 squared is 100. It's the cube root, so no plus or minus. Okay, so this would be 10 to the 1, 2, 3, 4 to the 1/4, and that's 10 plus or minus. Okay. Now, what if I asked a question, which answers would give you 10? This gives you 10, and this gives you 10. Yes, this does give you plus or minus 10, but 10 is part of that answer. If I said which answers give you 100, your answer would be just that one. Okay. Let's go to the next one. It looks like simplifying. A lot of these simplifying problems will probably be worth 3 points, and I put it on the test. So 32 is 2 to the 5th, which makes sense because it's to the 1/5. If you want to keep it in rad form, that's fine. I function better in exponential form. 2 in the numerator. This is like -1. So -1 to the 1/5. Sorry, -1 to the 5th to the 1/5 is -1. Yes, I'm showing my work. Yes, you need to show your work. X to the 10th to the 1/5 is x squared. So we get -1x squared in the denominator, but you know I do not want a negative in the denominator. 5th root, and it's negative, no plus or minus. Okay, there's a couple different ways to do this problem. But what I like about this is they both are 4th root, which makes me think there's going to be a plus or minus in my answer. So that means that when I'm multiplying exponents, I really add. Some of you are pile people. Some of you can just see it's x to the 16th, x to the 3rd, to the 1/4. So that's x to the 4th, and then x to the 3/4. Great. Or x to the 4th, fourth root of x cubed, plus or minus. I'll accept this answer. I'll accept this answer. I'll also accept you treeing it. So 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 16, 17, 18, 19. There's my whoopsies. What did I mess up on? Oops, I didn't do enough. 4, 8, 12, 16, 19. So 4 piles, that's my x to the 4th. I should make this closer together. And 3 left over x cubed, plus or minus. Exponential form, great. Rad form, great. But if I specifically say I want the answer in rad form, this is all I'll accept. If I say I only want it in exponential form, this is the only one I'll accept. Okay, the next one asks the cube root of 125 in 4 ways. Here is one way. Put the little cube in there. Okay. I could also say it's 1/25 to the 1/3. I could also say it's 5 cubed to the 1/3. I could also say it's 5. I could also say 5 cubed, cube root. I may give you bonus if you give me more ways. We'll see how it goes. Okay. All right. True or false? Notice what I'm saying here. You have to prove equality. You have to prove they are equal, and not because I used my calculator. So I can't do anything with 2 to the 10th. So what I need to do is make sure this looks similar to this. If I ended up getting equals 4 to the 5th, that's not proving equality or inequality, because technically those are the same thing. So you want to make sure that if this has a base of 2, this has a base of 2. So instead of writing 4 squared for 16, I'm going to write 2 to the 4th to the 1/3 to the 9th. So that's 3. And this is 2 to the 12th equals 2 to the 10th. And that is false. I'm showing that the bases are the same and the exponents are not. That's how I can compare them. Not because I picked up my calculator and figured out the answer. All right, this is 2 cubed to the 1/3. And this is 2 squared to the 1/2. This is 2, and this is 2. But this is plus or minus 2, because that's an even root. So that one's false. Let's go to the next one. I can't do anything with that, but now I know this base has to be 2. So that's 2 cubed to the 1/2. I don't know why I picked so many false ones. 2 to the 3/2 equals 2 to the 5/2. That is false as well. Make sure you are showing it to me like that, okay? All right, they want you to use exponential form to simplify this. So 20 to the 1/10 to the 30th is 3. 20 cubed. Yes, I said don't simplify big numbers, but you can do 2 cubed. That's 8. And 3 zeros. 1, 2, 3. Even root, plus or minus. Okay. Next one, 216. That might be difficult. So I'm focused on the 3. So I'm going to guess. I mean, I know what the answer is, but I'm pretending. So I'm going to go 4 times 4 times 4. Too small, 5 times 5 times 5. Too small, 6 times 6 times 6. Oh my gosh, it's a miracle. So it's negative 6 cubed to the 2/3. Yes, you need parentheses here because that's negative. That's gone. Negative 6 squared is 36. This one, it's like putting it over 1. So I have 13 on top and 5 on the bottom. More on top or bottom, top by 8. But it's the 6th root of 8. So you are finding piles of 6. 1, 2, 3, 4, 5, 6, 7, 8. So I have 1 pile, and I have 2 left over. 6th root, plus or minus. I could have also simplified this as x to the 6th, x squared to the 1/6, and gotten the same thing. Okay? Oh, actually, this is wrong, because I can simplify this even more. Because this, if this is x squared to the 1/6, that's actually x to the 1/3. So this is incorrect. This is why I don't always like piles and why I like exponential form. Because when I saw 2 over 6, that was 1 over 3. So this is the cube root of x. All right, let's go to the next one. All right, I want to make sure I don't forget that negative 11, so I'm going to highlight it because I know myself. Tree, 249, 7, 7. So this 7 is going to get multiplied to this negative 11. So negative 77 is on the outside. Let's do my square root. My 2 is left over. I'm looking for piles of 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some of you just want to go a to the 10th to the 1/2, and you get a to the 5th. The b's, 1, 2, 3, 4, 5, 1, 2, piles of 2, b left over, and then there's just 1 c. And there's no plus or minus because it's already negative. Next one, the cube root of 32, 216, 2, 8, 2, 4, 2, 2. I'm looking for piles of 3. So I have 1 pile of 3, and I have those 2 left over. 2 times 2 is 4. Don't forget the cube root. Okay? X to the 9th means I'm doing piles of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 17. Oh, this is annoying, but I'll do it with 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5 piles, 2 left over. And that covers everything, and it's the cube root, so no plus or minus. Okay, let's go to the next one. Simplify by putting the same together. So this is negative 5 and negative 2. That's negative 3, which means I know the x cubed has to go on bottom. The negative 9 just stays. And I know there's a 1 there, so I'm going to go 7 cubed plus 1 over 1 times 3 is 3 over 3, sorry. And that's 10 thirds. Oops, let's make it y. And I'm okay with a fraction in the numerator, so there's my answer. Okay, last one on the page. Similar to the first ones, 10 to the 1, 2, 3, 4, 5 to the 3/5, x to the 15th to the 3/5, 3x9, 3, and 10 cubed you can simplify, 1, 2, 3, x to the 9th. It's an odd root, so no plus or minus.